and I'm so sorry for the noise because it's raining now. So this time let's talk about applications of derivatives. Derivative in mathematics, the rate of change of a function with respect to a variable. Geometrically, the derivative of a function can be interpreted as the slope of the graph of the function, or more precisely, as the slope of the tangent line at a point. In maths, derivatives have wide usage. They are used in many situations like finding maxima or minima of a function, finding the slope of the curve, and even inflection point. A few places where we will use the derivative are given below and then explained one by one in the following sections. The most common usage of the application of derivatives is seen in the following areas. The first one is finding rate of change of a quantity, finding the approximation value, finding tangent and normal to a curve, finding maxima and minima and point of inflection, and determining increasing and decreasing functions. So let's go with the first one, which is finding rate of change of a quantity. The change in a quantity with respect to time is known as rate of change. If a quantity y varies with respect to another quantity x, satisfying y is equal to f times x, then dy over dx represents the rate of change of y with respect to x. The next one is finding the approximation value. We can use the linear approximation of a function f times x to find the values of f times x at the nearest values of a fixed number x is equal to a. The linear approximation is denoted by L times x and is found using the formula L times x is equal to f times a plus f of a times x minus a, where f of a is the derivative of f times x at a x is equal to a. The next one is finding tangent and normal to a curve. For each fixed value xo of the input to x, the value f of xo of the derivative f of f evaluated at xo is the slope of the tangent line to the graph of f at the particular point xo f times xo on the graph. The normal line to a curve at a particular point is the line through that point and perpendicular to the tangent. So the next one is finding maxima and minima and point of inflection. So there is no overall maxima. There can be as many inflection points as you like between two adjacent critical points. If you want an answer in terms of the degree of the polynomial, the maximum is the degree minus 2. An example with n is equal to 5. Take f times x is equal to 3 times 5 minus 30 times 4 plus 110 times 3 minus 180 times 2. And the last but not the least is determining increasing and decreasing functions. The derivative of a function may be used to determine whether the function is increasing or decreasing on any intervals in its domain. If f of x is greater than 0 at each point in an interval 1, then the function is said to be increasing on 1. F of x is less than 0 at each point in an interval 1, then the function is said to be decreasing on 1. So its importance lies in the fact that many physical entities such as velocity, acceleration, force, and so on are defined as instantaneous rates of change of some other quantity. The derivative can give you a precise instantaneous value for that rate of change and lead to precise modeling of the desired quantity. So thank you so much for listening, and that would be all. Thank you.